sorry?
12
In
and 15. 11, 2.
11:2. Oh, okay. So number 12. This is 11.2.
Put this up here.
So quiz on Monday and then test on Wednesday?
Yeah, the test is next Wednesday. I'll take a while. Well, that guy warms up. What was your question?
Oh, I was gonna ask number 6 on the 11.2. No, that's all right. I think 12. It's like along the same lines.
Okay.
They're all working.
Yeah, 6 is a geometrical problem. You see 12, Sven, Lori, and Isaiah. Right, number 12? So Sven, Lori, and Isaiah can process blah, blah, blah. They can do this together, blah, 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 blah. How many orders can each person process alone? So the question is where I figure out what my variable is going to be. So what variables am I going to use and what will they represent?
It's the first letter of their name.
That's crazy. So what would S represent? Sven, what about Sven? Sven's weight?
No.
Yeah, the number of Sven's number of orders. And then, of course, incredibly enough, L would be Laura, and Isaiah. Oh, S and I are just awesome. Well, S is fine. I is fine, I guess. I is good old Isaiah. Put too many A's in there, didn't I? Oh, no, I didn't. All right. So then, do you see how the equations sync themselves up? Each sentence is an equation, basically. Each part of these things. Sven and Lori, together, they can process 740 telephone orders per day.
So S plus L.
Yeah, so Sven and Laura and Isaiah can do 740 per day. So was the trouble with setting it up, or was the trouble with solving?
I had trouble trying to figure out how to solve.
Okay, so what's the second relationship?
Laura.
So S plus L equals 470. And if you notice, I already know what I is. I know what the variable I is. Lori and Isaiah can process 520. So Lori and Isaiah can do 520. So then I know what S is. Do you guys see what I mean? If I know S and L together is 470, S and L and I together is 740, what can I do with these two equations? I can subtract. Do you see? So if I take 1 and 2 and I subtract them, yeah, the S minus S, L minus L, I equals. So when there are variables missing here, there's almost always going to be a quicker way to do it than the by the book method.
That's where I wasn't sure. Like I wasn't sure if you could subtract the equation that was missing a part.
Oh, totally. Yeah, of course. Yeah, you could. So it doesn't matter because it's not really missing a part. It's just got plus 0 I, right? So all day. Or you can look at it as multiply this by a negative and then add them together. It doesn't matter how you look at it. But I can kill two variables at once. Anytime I can do that, hell yeah. If the problem is too many variables, then I can kill two of them at once. Kick ass. And then you can do the same thing between these two to figure out S. And then once I know S and I know L. Or if you want to look at it a whole different way, you ready? Here's a different way to look at it. S plus L is 470. So can't I rewrite equation number 1 as 470 plus I equals 740? Right? Substitution. What is S plus L? 470. So wherever I see S plus L, I can put 470. And then I can subtract and get I. And do the same thing with this information in there. Right? Put the 520 in there. Cool. Okay. Anything else from homework? Yeah.
I would say 15, I put them down as well.
Oh yeah, all right. That's awesome. So let's see, 15.
I wasn't sure where to put the 1600.
Oh, okay. All right. So let's see, everybody's got this here? So where do you start? You always have to start a word problem with
Sorry.
the variables, right? So what is it we don't know here? Let's see.
How much did you borrow from each so?
Yeah, exactly. So how big was the bank loan? How big was the small business loan? How big was the mortgage loan? So it looks like I can use the letters B, S, and M to figure out how big each one is. So B would be the size of the bank loan. S is the size of the small business loan. Small biz. And M is the mortgage. Alright. So you've got to start there. You've got to give the parts of the problem math names. Because then I can put together math sentences using those, which we know of. They're equations. That's what equations are, math sentences. So let's see. The very first sentence, what can I do with it mathematically?
So these 3 equals.
Yeah. So B plus M, that's good, John. B plus S plus M equals 120,000. There's one equation. And I told you, there's almost always one equation is going to be real easy. It's the total of your variables, right? Almost always, not every time. Let's see. Her bank loan was at an interest rate of 8%. The small business loan is an interest rate of 5%. So let's put that. So this would be. Let's put that over here. 8%. Where'd you go? 5%. And the mortgage 4%. Right. And you're like, why did you just take everything out there? The total interest due in 1 year was $5,750. Now, do you know how interest rates work? This is not something you have to go to your bank and get help with. It's just purely, what does that mean that the bank loan was 8% interest?
0.08 times B.
Exactly. Whatever the amount was she took out, she's got to pay 8% of it per year. That's simple interest. So 8%, how do I write that?
0.08.
Good. Because math doesn't understand 8%. That's human construct. Math needs the number. The number is 0.08. 8% of the bank loan amount plus 5% of the small business loan plus, man, S is a bad letter for me. 4% of the mortgage.
Equals 579.
Yeah, equals the total interest. So the interest from her bank loan plus the interest from her small business loan plus the interest from her mortgage equals the total interest per year. Whew. So most of the problems in this section, the first sentence is the first equation, the second sentence is the second equation, that kind of thing. That almost always happens like that. And then it tells me at the end, now here's where it gets a little more interesting. The annual simple interest on the mortgage. Now what represents the annual simple interest on the mortgage? I've got it up here somewhere. What represents that?
4%.
Yeah, this piece. That's the annual simple interest on the mortgage, right? So the annual simple interest on the mortgage, that, no, Jeff, there you go, dude, was, that's a key word for equals, right? Is a key word for equals. Was also equals. $1,600 more than the interest on the bank loan. Yeah, so the bank loan was 0.08, and then that would be $1,600 more. How are we doing so far? So, do you see how that sentence just directly went into math? The interest on the mortgage. Did I do that right? Yes, good. On the interest on the mortgage was $1,600 more than the interest on the bank loan. Bam! That's the sentence in mathish.
And then you can do by substitution.
Yeah, and if you want to, of course, if you don't like decimals, you could take each of these and multiply by 100. Move all the decimals over twice, if you want to. Now you can do elimination, whatever the hell works, right?
You can solve for n and then substitute for n.
Yeah, you know what m is in terms of b. So you can plug that in here and there. Yeah, it looks like a good way to attack it. It's not the only way you can do it, but that looks like a good way to attack it. We did one like that the other day. Yeah. Is that good enough? Who asked that question? Or who's interested in the question? Is that good enough? Yeah?
Yeah, I just had problems setting up that number 3.
Oh yeah, that's right. You weren't sure where to put the 1600. But it's so you say the annual interest on those.
Makes sense.
What did I have for breakfast? The annual simple interest on the mortgage was $1,600 more than the bank. Yeah. And the reason I write this like this is because if it said $1,600 less than, if I put this second, I'll never make that mistake of doing that backwards, right? So this one I know you could write this either order, but I always just put that guy second always, just so my minuses don't freak out too. I don't know if that makes sense, but all right. Cool. All right. Anything else from homework? Which everybody's doing? I thought I'd give us a break. I figured today I could have one day where I don't wear math. We talk about math. I was going to wear this shirt, but it's all beat up. It's this old shirt, and you would appreciate this joke.
Absolute luck.
Absolute luck, yeah. The only time that somebody got that, I was in the airport in Seattle, and somebody started laughing at me. I'm like, oh yeah, hey, you got my shirt. I'm like, yeah, I get your shirt. You're the only one who's ever gotten my shirt. Everybody else just looks at me like, lush. Fun. Get away from me. All right. Cool. So anything else from homework? That's it? Okay. Anybody came in that didn't get their stuff back yesterday? Wait. And real quick, the people that just got your test back, oh, did you need it? Oh, yeah. Or did you have a... So you didn't get yours back yesterday? Did you get your test back yesterday? Oh, good. Okay. So the people that just got your test back, there's a green grade, which is your original grade. There's a blue grade, which is your curved grade. And then there's 2 black grades on the other side of your test. The first one is your current average, and the second one is what your average would be if you made corrections to the test and got them all right. Okay, yeah.
When are the corrections for the homework due? Is it before the quiz or before the next test?
Corrections for homework are due by the day of the final exam.
Oh.
Yeah. The final is going to be cumulative, so it's going to have everything. It's not really my decision, but if it was up to me, that's what I would decide anyway. So just to be totally upfront. But as the math department as a whole, we decided, if you're going to pass the class, you got to show us, all the shit we talked about. Only makes sense. You shouldn't only know it for long enough to get the test done, and you're like, I got the test done. No, that doesn't make any damn sense. All right. So we're going to get into chapter 12 today. Remember 11.5, I made extra credit. You can do it or not. It's up to you. And let me just kind of start off with seeing where we are with this idea. And just to do a little preview too, you guys have heard of logarithms?
Yeah.
All right. We're not there yet. We will be. Normally people dislike them. Is that true?
Yes.
All right. Are like square roots hard to do? But are they really, really hard to do? I mean, what's the square root of 49? Why? It's 49. Exactly. So what you've done that is the reason that logs are hard is because you guys don't know what the symbol means and you don't remember. If you know the question that the symbol represents, do you know what shorthand is? You ever seen like court stenographers going away? And they actually have these weird ass looking keyboards that have shorthand for words. So it's like, if I write this, what is that shorthand for? Take the number 3 and multiply by itself. Right? I mean, that's a long, I don't want to write that every damn time. So that's the shorthand for that sentence. So this is the shorthand for what does it take 2 of, because there's an understood 2 here, right? What does it take 2 of to make 49 when you multiply them? It takes 2 sevens, right? So you guys, maybe that's not the question you ask yourself, but you have internalized what that symbol means. Does that make sense what I just said? So the symbol, this symbol, the question it asks is, what does it take 2 of to multiply to be the inside number? Right? Yeah.
Doesn't it equal a plus or a minus 7?
No, careful. I appreciate what you're saying. So in general, if I have this question, what do I square to get 9? Plus or minus 9. Plus or minus 3. So that's where you need plus or minus, because there are 2 things I can square to get 9. The square, if this symbol means the positive root. So for every number there are 2 roots, a negative one and a positive. But when if I wrote this, that specifically means the positive. If I want the negative answer, I've got to write that. Cool. So this is called the principal square root, which means the positive option. I like it. Cool. So be careful. Square root of 49 is not equal to plus or minus 7. It's plus 7 because they chose the positive one. Good. I like it. So glad you brought that up. All right, how are we doing so far? All right, no answer. Shit. It's early, man. I've already crushed you. It's supposed to take me longer and get too good at it. All right. So when we make it, I'm not going to talk about logs today, but when we make it to logs, we just got to do the same thing. We're going to say, what the hell is the question that this symbol is asking me, so then I can internalize it and I know how to attack the problem. And normally, teachers don't put it like that. If you just realize that's what you got to do, it becomes a lot easier. So you'll have to wait and see if that's true when we get there. So real quick, let's do a couple of square roots. What's a negative square root of 16 then?
Negative.
Beautiful, because it's square root of 16 with the negative on it. So that's the negative 4 option. But what's the square root of negative 16?
No.
Not real.
No, no.
Yeah, not real. Or can't do right now. Ask me later, because when we get to section 12.8, you'll be able to do that. Some of you guys know that the answer is 4i, and the rest of us are like, what? For you? So this is section 12a, but right now you just say not real. If you put 4i, I can't take points off because you're right. But really, right now, all we know is it's not real. And why is that not real? What? Yeah. But so what is it? So why is this? Let me make that for a second. Why is square root of 16 4? Because 4 times itself is 16. There's no number that I can multiply by itself. 4 times 4 is 16. Negative 4 times negative 4 is 16. Shit. So there's no number, no real number, I can multiply by itself to make it come out to be negative 16. It can't have different signs because it's supposed to be times itself. Cool. Okay. What about this then? This always freaks people out, but why is this not that big of a deal? Let's see if you guys are cool with that. Yeah, exactly. Ooh, it's a fraction. Who cares? Square root of 9 is 3. Square root of 64 is 8. So 3/8 times 3/8, of course, would be 9/64. Kick ass. Yes, sir. Oh, you good. You just, okay. Agreeing with my crossed fingers. So what the hell would this mean then? And of course, the question that asks is, what does it take 3 of to multiply to be 8? Right? So it takes 3 2s to multiply to be 8. So one way you can attack this is to start to break this down. And the minute you get 3 of something, that's your answer. Right? So if I ask you a question like this, can you do it, Jeff? Yeah, you can do it. There you go. Good job. Yeah, exactly. That's not one that's in my brain. Normally, it's in my brain, but it's not in people's brains that aren't math teachers, right? So what you start to do is you start to try to break that down. So can somebody figure out something that goes into that number? It's not even. The numbers don't have to be a multiple of 3. So you can kill 2, you can kill 3, you can kill 6, you can kill 9, 7. So 7 times what? 49. Shit. And what's 49? So what's the cube root of 343? 7. Because it takes 3 of these to make this. Kick ass. All right. Now here's the neat thing about odd roots compared to even roots. In fact, just to kind of build up to this, what is negative 2 times negative 2 times negative 2? Right? Negative 8. So what's the cube root of negative 8? Negative 2. It's not real. So why are cube roots able to handle negatives, but why are odd roots able to handle negatives, but even roots can't? Yeah, because if I have an odd number of negatives, it's going to stay negative, right? There's going to be one negative left alive. If I have an even number of negatives, everybody kills each other. Cool. I like it. So if I ask you, what's the 5th root of negative 32? Negative 2. Because 2 times 2 times 2 times 2 times 2 is 32. And they all have to be negative. 5 negative 2's multiply to be negative 32. Kick ass. Right? So that's relatively easy because we know what the symbol means. When we get to logarithms, we don't know what the symbol means. If you just know what the symbol means, then they're going to be just as easy. You guys don't believe me right now, but I don't care. We're not there yet. Alright, that's not too bad. Here's a freaky one that's in the homework. This always freaks people out. Let me get way up there on my Roman numerals. What's the square root of 0.04?
0.2.
Now you're thinking backwards.
0.2.
0.2. The square root of 0.04 is 0.2. Because do you remember when you multiply 0.2 times 0.2, you get 4, but then you have to move it back twice. So you get 0.04. So what's the cube root of 0.008? See how I'm now 1, 2, now I'm 1, 2, 3. So that's just going to be the same damn thing. I like it, because if I multiply by one more 0.2, it would have to move one more decimal back. Oh, shit. So now there's people like, how do you do cube roots in your calculator? Just to warn you, normally I have it on this test, I have 2 parts to it. One part without a calculator, one part with. So don't get too dependent on your calculator. Okay. So that's the basics. So what's the next level of this? Well, the minute we have a new operation, so this root idea is a new kind of operation, I want to look at what would it look like visually. So we know how to handle it computationally, but now I want to know what does it look like if you graph it. Do we have to, Joe? Yeah. And really, when you want to know what it looks like when you graph it, you actually have to know what variables, what values am I allowed to use? What is the domain of this thing? And you should be able to tell me without doing any work, what's the smallest number you could put in there and have it come out real? No. 0. Because the square root of 0 is? 0. Sweet. So the domain for this is 0 to infinity. It just can't be negative, right? Because then it would come out complex. Okay, cool. I like it. So you guys, what would be smart for me? 0 is smart because the square root of 0 is 0. 1 is smart because the square root of 1 is 1. Is 2 smart? 3? 4? Yes, because I'm trying to do this by hand, right? I don't want to try to graph the square root of 3. I'd much rather graph the square root of 4, which is 2. And maybe one more, the next good number is?
9.
That's crazy.
3.
3. Real quick, watch this. How far apart are these?
1.
How far apart are these?
2.
How far apart are these?
5.
The next good one would be
7. 16.
16, and they are 1, 3, 5, 7. So all squares are separated by odd numbers. Yeah, it's kind of nifty. Anyway, that's a little side note. So now I want to graph this thing. I just got to plot those points. Put that little negative down, poor little dude. So 0, 0, 1, 1, 4, 5, 6, 7, 8, 9, 9, 4, 2, 9, 3, and there it is. Become big. Okay. Now, what does that look like if you do this? What does that look like, sort of? Half of what? Parabola. Sweet. And why does it sort of make sense? Because the square root is kind of the opposite of squared. So it's like a parabola that fell down and lost its bottom half. Poor little dude. And of course it can't be down here because the square root can't have negative outputs, right? Alright, cool. Y'all doing alright? You guys alright? Looks like some of you guys had too good of a Wednesday night. I don't know. Almost here. Okay. So, I mean, in this section, they're going to give you some where, like, it's... let me give you this here. What would the domain be for this? That's where we get interesting now. Let's see if somebody can tease this out.
4/3.
Sorry. So what's got to be true about the number inside? What's got to be true about it for this to work? Not just positive. At least what? 0. So it's got to be bigger than or equal to 0. So do you see how anytime I ask you for the domain of something, you say to yourself, what must be true? So like on this problem, how do I get the domain? I say the bottom must not be 0, and then I solve it, right? So on this one, the inside must be at least 0. I write that in math, and I solve it. That's how you do any domain question where they give you the function. You just write what the restriction is and solve it. So to solve this, what do I do?
Minus 1.
Good. X less than or equal to 4/3. I like it. Cool. Why does it make sense that my inputs can be negative now? Can't they? Because less than 4/3, like negative 80. Because it would be minus negative, so it would be plus, so the inside comes out positive, which makes it good. I like it. All right.
So what would that be in implementation? 0 to that, or would that be?
No. So if it's less than or equal to 4/3, what's the smallest it could be? negative infinity, and then it has to stop at 4/3 with what? Bracket. Cool, because I want to include it. I like it. Kick ass. Yes, ma'am.
Instead of the sign for greater than equal to 0, shouldn't we use the equal sign instead of the sign?
No. No. Because, and if you use an equal sign and you solve it and you have equals here, what is there to tell you that it should be less than? You would just put that symbol back in, or I'm not. Do you see what I'm saying? I mean, finding where equals 0 is important, but it doesn't give you the whole picture. You got to be on the right side of 0. So you have to use an inequality symbol here. Because that's really the restriction. The inside's got to be at least 0. Cool. All right. All right, so here's a semi-evil question. Don't say anything out loud. What's the domain of this one? I said semi-evil because there's something about it you've got to notice, and if you notice it, it's easy. So why did this one have to have an inside that was positive? Because what kind of a root is it? Yeah, that has an odd root. Do odd roots need the inside to be positive? No. So what's the domain? Beautiful. If there's no restriction, the domain is all real numbers. That makes sense. If there's no restriction, you can use whatever the hell you want to use. So this would be all reals, or R with an extra spine, or negative infinity to infinity. Any of those things mean the same thing.
That's when it's to any negative root.
Odd root.
Odd.
Cool. I know what you meant. I say that sometimes too.
What makes it restricted again?
Even roots. I can't do the square root of negative 16, right? So the inside's got to be at least 0. Odd roots, I could do the cube root of negative 8. I could do the fifth root of negative 32. I could do the roots of negative. So there's no restriction here. So I don't have to throw out any numbers.
So anytime it's an odd square root.
An odd root.
An odd root.
Yes.
With a variable inside, it's all real numbers.
All real numbers.
Always.
Now let me show you the ultimate evil. You ready? The ultimate evil. Alright, so it's a 7th root, right? Which is good. But then the inside looks like this. So is there a restriction because of the root? No. Is there a restriction because of something else?
Yeah.
Yes. In this case, x can't be beautiful. But this guy didn't add any restrictions. There was a restriction just because there's a variable on the bottom. I can't let that be 0.
So it would be negative infinity to negative 5 not included, and then negative 5 not included to infinity.
The gas. Yeah, because I want to skip negative 5. Sweet. Okay. Alright. Make sure I don't miss anybody. Alright, here comes an interesting question. This is sort of related to the absolute value. This is sort of related to what somebody said earlier about plus or minus. Here we go. This is a little evil. What is the square root of x squared?
Opposite.
It's not x.
Opposite.
Yes. So here's why it's not x. If I let x be negative 3, you with me? Then that would be the square root of negative 3 squared. Well, what's negative 3 squared?
9,
And what's the square root of 9?
3,
Is that x?
9.
No. It's the absolute value of x. Oh, shit. So the absolute value actually comes in and saves her ass. It says, so square root of x squared. Square root of something cannot be negative. So if you say this, you're wrong because x could be negative. So the way you take care of it is make the damn thing always positive. There we go. Yes, sir.
Can you put a positive sign in front of it, or you just have to put it in the
But see,
absolute?
if I do this, there is a positive sign in front of it, right? And if I do this, it doesn't take care of, if x is -3, that's still negative. Positive -3 is -3. It's the fact that x itself could be negative. That's why I have to have an absolute value around it.
Whatever the number is, it's positive.
Exactly. Yes, ma'am.
So if it was a cube root,
I love it. Look at you going where I was about to go. Sorry.
then you can have it be just a negative number.
So the cube root of x cubed
X.
Positive, negative.
X.
is x. Bam! Because the cube root cancels a cube, doesn't it? Just like the square root cancels a square, but the answer could not come out negative. Here, can the answer to a cube root be negative? Of course, we did one earlier. What's the cube root of -8? -2. So I don't have to put absolute values when it's an odd root. So in general, odd roots, very laid back. Like, whatever. You're negative, stay negative. I can take negatives, sure. Even roots, oh shit. Can't take negatives in and they can't get negatives out. Yes?
So the cube root of x cubed could be, would that be all real numbers?
Oh, if I was talking about the domain, sure. Yeah. But in that respect, I don't want to confuse domain with what we're doing. This is simplification problem. But the domain of this would be all real numbers. Because think about it. Can the inside be negative?
Okay, but it'd have to be all.
Can the inside be negative?
Yeah.
So give me a number, the real number that you square comes out negative. Tell me. That's what I thought. So can the inside be negative? No, because it's squared, right? Do you see that?
But it could be negative as long as it was absolute value.
Well, and this is, so there's two questions. Domain asks, what am I allowed to put in? So I could put whatever x I want to in there, because I square it, so then the square root won't freak out, right? What makes the square root freak out is if the inside is negative. If I square a real number, will it ever be negative? No. So the domain of this would be all real numbers, because I'm squaring the inside. The inside can't be negative. But the output, I don't care what the hell's going on inside, the output cannot be negative. So that's why I need the absolute values around that. Is that cool? So there's a difference between domain, what are you allowed to put in, and then what comes out. And in this case, I had to put this here so the output would be the way it's supposed to be. It's got to be positive output. All right. Which really, let me show you this. Remember that earlier problem we had like this? Let me show you all the behind the scenes of what's going on. What would I do to both sides to kill the square? What kills the square? Square root. Well, what's the square root of x squared? So then x equals, right? Absolute value has two cases.
Wouldn't it be 3?
3. I keep putting 9. Thank you. And normally what we do when we get to this section where we solve these equations, what I tell you, instead of doing this all the time, and what some of you guys have been told before, is the minute you put a square root down, you put plus or minus, right? And that's why, because it really would be an absolute value, which would have two cases. So very often we skip this step, but that's why we do what we do. It's because this step is there. All right. I can't read you guys today. Worth shit. Okay. Like I said, I never want to play poker. Any of you. All right. So what about this? Let me start off nice. Sure. Square root kills a square. So then the answer, it looks like it should be this, but
Absolute value.
so be careful about putting plus or minus. It doesn't really work here. It's the absolute value. Because the absolute value will only change the sign if it happens to be negative. If you put plus or minus, you're saying both answers always work. No, there's one answer. There's one answer to this. If it happens to come out negative, the absolute value will make it positive. Right? So you would, if I ask you what's the square root of 9, you would not say, you can do it, Jeff. You would not say the square root of 9 is this, right? you would say square root of 9 is 3. Okay. So what about this here? This is like the next level up. And you can see why. Let's see. Alright, this is where you got to be really careful. This is the problem.
Yeah,
Thank you. This is the one where my Math 280 students, I like to rip on them. I tell them I rip on them. I'm not teaching them now, but last semester, they couldn't handle this. And I'm like, you guys, this is something I would come down on my 110 students for. Do not make this somehow x plus, I don't even know what you put there, plus 5. No. Square roots cannot distribute across addition. In fact, square roots are equivalent to exponents in order operations. Later today, we're going to prove that square roots are a type of exponent. Right? That sounds freaky. So to do this, you got to make this look like that. Why did this work? Because the square root will totally kill an exponent, because the square root is the opposite of squared, right? But it can't do a damn thing with addition, shit. Square roots are not based on addition, they're based on multiplication. So how do I factor this? Yeah, so x plus 5 squared. And square root of that, these cancel, but then you have to put x plus 5 just to cover your ass in case that comes out negative. Okay. And so one last one of these. What about the fifth root of, it doesn't matter, 3x minus 2 to the fifth power. Now ask about domain. Just what's that? Simplify that. Yeah, so I hear a couple things. Do I need absolute values here?
No.
Because it's an odd root. Odd roots can come out negative. They don't need absolute value to clean up any mess. They're like, well, it's okay. Odd roots, very laid back. Even roots, very, oh, no, it's going to be positive. Right? Okay. All right, so let's take the next level. We're just going to keep leveling up, right? That's what we do in math. Thank God I do have a couple of handouts, so I'm not going to talk all damn day long. But I'm going to talk for a little while longer. Let's see. That's all right. I can take that. Let's go one step up here. What do you think about this? That's an A. Let's make it an X. There you go. X to the what? Now think about it. Technically, it would not be wrong, but can x to the fourth be negative? No. So do you need the absolute value to clean up the possibility of it being no? But if you put an absolute value, I'm not going to say you're wrong. I'm just going to make a note saying you don't need them. These are unnecessary. You don't need them because the answer can't be negative. All right, I'm going to let you absorb that. Yes, ma'am.
Why is it 4, the square root of...
Oh, good. So what's the square root do to something? I'm gonna say this, so I want you to know what I mean. It cuts things in half, multiplicatively, right? So if I have 9, the square root of 9 is not 4.5. You don't cut it in half additively, right? So think about this difference. 9 divided by 2, if you cut 9 in half additively, it's 4.5. Square root of 9 is cut 9 in half multiplicatively. So you see the kind of like the analogy there.
Yeah.
Good, I love it. So if you cut this in half multiplicatively, you just cut 8 in half. In fact, how would you factor this, x to the 8th minus 16? You cut it in half, x4. I mean, that's, you're square rooting when you're doing difference of squares. You are square rooting everything. And another way to check it, what is x to the 4th times x to the 4th? X to the 8th, because you add powers, right? I like it. So be really careful. This is what drives me a little crazy. You understand, if I write this, we're not quite here yet. Some of you guys realize why this is not easy? Because you can't cut 9 in half nicely, right? But I often get people telling me this is x cubed. Where would that come from? This is wrong, by the way. Don't put that down. They're looking at it as square root of 9. I'm not square rooting 9. I'm square rooting x to the 9th. Is there any 9s in here? Nope. There are 9 x's in here, right? So it's different. You gotta be careful.
What if there was a 3 on the outside?
Do it again.
What if there was a 3 on the outside?
Oh, sure. So if I have the cube root of x to the 9th, what would that be? Cut it in how many pieces? X to the 3rd. Let that be easy. It's almost too easy to trust. Right? You're like, that can't be it, but that's all it is. You already know when you do cubes, you cut things in thirds. You've already been doing this. You just cut it in thirds, cut it in half. Exponents are awesome when you're doing something related to multiplication. That should be easy because exponents are based on multiplication, right? So this is all about what does it take 2 of to multiply to be this. This should be easy to do with exponents because they're based on multiplication. Yes, sir?
Can't you just say that they cancel each other, so the 3 cancels and then the...
Well, 3 goes into 9.
Yes, can't you just do that?
Well, that's what we got there, yeah. But 3 goes into 9 3 times. 2 goes into 8.
Yeah.
4 times. Cut it in half, yeah. Cool. Yes, sir?
So is there a case where going to see the square root of x to the 9th, it would be x to the 4.5, or that?
No. So here we go. Let's see how to handle that. You ready? If I had the square root of... Well, it's getting a little ahead of us. Well, let me build my way up there. I'll put it up here. I'll remember. I got to explain a few more things before you can do that. All right. Let me make sure. I don't want to miss anybody. Cool. Sweet. So believe it or not, we're basically done with section 12.1. All right, here's the big thing. Here's the key thing. We're almost to this point. So let's just investigate something for a second. Remind me, what happens when I have like x squared to the 5th power?
Multiply 5 times 2.
Good, so you get x to the 10. Cool. So let's just investigate this. We normally always put integers or integers. We never put fractions there. In fact, I don't even know if you ever thought for a second, what would a fractional exponent even mean? And you're like, that sounds painful. Can we just not do that this semester? Right? But it's super nice. We've already figured it out. We already know. We've said it, believe it or not. So let's see. Watch me. So if I have 3 squared to the 1/2, what do I do with the powers? So what's 2 times 1/2?
1.
So that's 3 to the 1st power, right? You with me? But what is 3 squared? What is 3 squared? 9. And what do I do to 9 to make it 3? What do I do to 9 to make it 3? Square root it, right? So this must mean the same thing as that. A 1/2 power is the same thing as a square root. Why does that make so much freaking sense based on what we just said a second ago? What's the square root do to something? It cuts it in half. And what's a 1/2 power going to do to... What is a power based on? Multiplication. So doesn't this mean half of this multiplicatively, which is exactly what this means? Good. So some of you guys must have known that coming in, hopefully. Maybe some others have forgotten that. Does it make sense why that is true? So this has always been weird to me. We really did not need to create this symbol. We really didn't need it, but it just came out before they really knew the connection. So we have both of them out there. Does that sort of make sense what I'm saying? So if I wanted to write the cube root of x, how could I write that with an exponent? X to the what power? 1/3. Because what's a cube root do? Cuts things in thirds. So it would be the same thing as x to the 1/3. Cool? So just let's prove that real quick. What's the cube root of 8? 2, right? And how can I rewrite 8? I can rewrite 8 as 2 to the 3rd power. So there's another way you can do that, right? Just kill the 3's. But now I'm saying I could write this as the cube root would be the 1/3 power, right? You guys kind of with me? And then of course what would happen here? You'd multiply and they would cancel. So it makes sense then that the 3rd power is the same as the cube root, the 1/5 power is the same thing as the 5th root. so forth. Cool, I like it. So, but that's nice for 1/3, 1/4, 1/5, but what if it's 3/5 power? Oh shit. That's nothing major. Watch this, you ready? So x to the 3/5. This would be, you guys believe me if I say this is x to the 1/5 cubed.
Yeah.
I like that. You're like, I don't believe a damn thing you've said all semester, man. I'm just collecting evidence. But why is that true? Because 1/5 times 3 is 3/5. But couldn't I write that also, just as a side note here, couldn't I write that as that then? It doesn't matter how I break it up, right?
No,
Become a 5.
3/1 times 1/5 is still.
It's still 3/5, right? But what does this mean? What's x to the 1/5? What's another way I can write x to the 1/5? The 5th root of x. So this would be the 5th root of x with a 3 on the outside. How do I rewrite this? This would be the 5th root of x cubed. So to see the power could be on the outside or the inside. Doesn't matter. But watch the shortcut here. So if I have a fractional power, the bottom is the root. Why does that make sense? What's on the bottom of plants? Roots. That's really sweet. So the bottom is the root, and the top is the power. It's powerful sometimes. Whatever makes it stick in your brain. So if I had, for example, if I had 7 to the 3/8 power, how would you rewrite that in root form?
8th power.
8th root,
8th
7, the 3rd, or you could write or 8th root of 7, the 3rd. Either way, I don't care. You see that? As long as 3 is the power and 8 is the root, because it's on the bottom, it's valid. It works. All right.
The denominator is the root.
Yes.
Oh, here. Sorry, yes. I wanted to see who was speaking to me. All right, so a little more talking for me, right? You expect that. This happens. I know, it's a lot. The consequences now of understanding what fractional exponents means, I have to go back and reinvestigate what does that mean about everything I know about exponents. Nothing changes. Remember that the thing I keep saying over and over is any process in math does not give a shit what's in there. It doesn't care. What do you do when you multiply like bases? You add the powers. Well, what if the powers were s and t? Well, then it'd be s plus t. I mean, the process doesn't give a shit. So if I had this, for example, x to the 1/3 times x to the 2/9. How do you simplify that? What do you do with the powers? You add them. Careful. The process cannot change. You've got to remember your properties of exponents. You don't have anything new to memorize. They're all the same damn properties. But to add these, what do I need? So it'll be x to the 3/9 plus 2/9 is x to the 5/9. Cool, I like it. And then you could change it to root form if you had to for some reason.